Hi, welcome along. I'm Dubba. I'm Director of Music Tech Fest, and this is the MTF Podcast. Now, MTF Stockholm in September took place at KTH Royal Institute of Technology, where they have some very brilliant professors working at the cutting edge of science and art, often both at the same time. Danica Kragic is a professor at the School of Computer Science and Communication. She's currently the lead investigator on a groundbreaking 10-year, 1 billion krona AI research project funded by the Knut and Alice Wallenberg Foundation and bringing together academia and industry across a wide range of verticals. Her research covers robotics, computer vision, and machine learning. She also happens to be a fashion designer and seamstress in her spare time. Danica joined us as MTF's Woman in the Lead of Robotics and AI in the MTF labs that took place in the decommissioned underground nuclear reactor chamber at KTH. She also grabbed the moment to sit down with Reuters journalist and MTF host Jamillah Knowles on the MTF interviews stage. From MTF Stockholm, Professor Danica Kragic.
All right, ladies and gentlemen, and everybody generally here at the Music Tech Fest, we're going to start off with another interview, and it is my pleasure again to be talking about design crossovers and technology with a woman who I have not met before, but I'm extraordinarily impressed by. I'm sure you will be too. Can we please have a round of applause, please, for Danica Kragic? So, obviously, it's part of what I do to stalk everybody thoroughly and find out all about them. But we need to know what you do. So, can you explain a little bit more about your work? And also, I don't know, like to call it hobbies, because it's important work too. But tell us what you do.
So to start with, my office is like 100 meters from here, so I'm local. I'm from KTH, so I'm professor in computer science. And now for like 22, 23 years, I've been doing research in the area of robotics. So I work with physical systems, and when I say physical, it's a robot with arms, usually on wheels. We have some robots on legs, but so what we do really is we develop software that uses information from different types of sensors that robots are equipped with, and we generate what we call intelligent behavior. So we want robots to understand where they are. We want robots to interact with humans. We want robots to interact with the environment in terms of picking up objects, putting them down. And the grand idea of me and many that are doing this type of research is that once we will have robots that can do all dirty, dull, and dangerous jobs that we humans do today and that we would like robots to do in the future.
So there's a lot going on there in the research that you have, and say going back not that long in robotics research, robots quite often didn't know where they were, which then leads to problems as to where they want to go. If you don't know where you are, you're not sure where you're going. So what are the advances that are making your work a bit easier? Are the technologies that basically mean you're able to take more of a leap in this field?
So I would start with sensing, because this is something that we humans take for granted a lot, our senses. The ability to see, the ability to feel, the ability to feel smell, hear, and so on. And what we are so good in is that we integrate all these senses all the time, in real time, and use this to interact with each other and interact with the environment. So building artificial sensing has for quite some time been a big challenge and still is. And also covering robot body with something that would look like or have the functionality of our skin. Cameras, they can generate images, but then you need lots of software in order to understand what's in the image. So I would say it's this interplay between building artificial sensing and then also building algorithms that can understand what sensors actually measure and generate some form of a knowledge representation. But not let's say like this, nothing of that would be important if you did not have the ability to move about in the environment. So you need to use senses for the purpose, in most cases, for while moving around, you need to detect obstacles, you need to avoid them. So that's what I mean by intelligent behavior. If you want to physically interact with the environment, not just push things around, but if you want to pick them up, having the ability to, have some form of articulation, like in terms of arms, hands. And I would say that that's still what a big challenge is in the area of robotics, and I would say industrial robotics too, and Shiva is here, she's going to say a little bit more about that. You can build a hand, but if you can't cover it with skin, again, there are still, thanks God, otherwise I wouldn't have a job, right? But challenges.
And so, that's certainly a good way of looking at what's happening inside a robot. But outside of robots is us. And we are fleshy and soft. We are easily damaged. You can't drop us from a great height.
Well, you can, but then...
we don't bounce quite as well as a robot. But it also means that our interaction can be led by fear sometimes. So if you've got something large and metal coming towards you, what can we do to mitigate this? Because, robots are very interesting. Obviously, they're a huge part of our culture as well. But it can be a bit frightening. So what do you advise when it comes to making robots a bit more acceptable?
So it's a very multidimensional question because it has to do partially with our perception of technical systems. And to start with, if you have a technical system that solves effectively something for you, the brain just has a tendency of accepting it. So even if you maybe in the beginning are scared of it, your interaction, spending time with using it, understanding it, makes also the perception of it easier. I'm very much against building robots that look like humans or are direct replicas of humans. We have that in Japan. We also have now that in UK, or Hanson Robotics and Sophia and so on. Why am I against that? Well, at least for some time, until we have robots having all the abilities of humans, or even more or better abilities than humans. Because if you're an untrained user, and by untrained I mean somebody that is maybe not in the technical area, somebody that is potentially scared from the beginning, anything that looks like human, you have human expectations on. And we know how it is for us humans when we meet another human that maybe doesn't speak our language, that comes from a different culture, that doesn't have the same values and things like that. We become reserved. So it's also between us. It's not only between us and technical systems. So I would like to avoid fuzzing people, if I can say like that, especially now in the beginning, but the technology is still very, very young. So that's one thing. The second thing is we can't completely disregard human body or be inspired by human body. And that has a little bit to do with the environment around us. So everything that we see around us has been adapted to our bodies. The ability that we can sit makes the chairs of certain size and of certain shape. The ability that we drink or use mic or a pen. If we didn't have any fingers, or if we just had just one, the world around us would probably look completely different. So now you want to deploy a robot in the environment and want it to do cleaning or picking up things, potentially ironing, with an iron at home,
Very much ironing for me.
Very much ironing, yeah, I can understand. But it's the same, so you can't really, since, evolution has given us this body, we have throughout our history built things and objects to fit our body. Now you would like to build something else that is as effective, and that's not going to happen. Do you understand what I mean? So somewhere we maybe need to learn how to address or develop the mechanical design but potentially the face, or it doesn't need to look the same. Mm-hmm. And this is, for those interested in mathematics, it's a really interesting mathematical problem. You can see it as an optimization problem. So how do you build another kinematic design or something like that that is as effective and that you can guarantee is as effective, but doesn't necessarily look as a human.
Interesting. All right. So there's been civics issues in different countries as well. So we've got like delivery robots now that are bringing your groceries to your home. That's great. And questions like, where do we put a lane for a delivery robot in a city after we've got the bicycles, which I quite often look the wrong way and get run over in Sweden. Sorry, cyclists. Yeah. But also then the cars and then the pedestrians and then, whomever else. So I certainly see what you mean, trying to fit robots into our world.
And the problem is that you can't just deploy technology and say it's going to work from the beginning. And this is also what we expect, because we have seen lots of Hollywood movies, and in movies everything is perfect and everything works from the beginning. You can't do the same now, because we are just not used to this type of systems in the physical world. Of course, new technologies, virtual reality, augmented reality, can be used to train our brains to get used to these things. But it's a challenge for our brain, because our brain is not used to maybe go around with a HoloLens whole day and generate kind of an overlay on the regular environment, so that you actually see virtual robots coming toward you and you kind of like finding a new pattern for walking or something like that. So there are ways how you could potentially train everybody, but we are just not yet there.
Okay, well, I want to turn a bit of a corner here in a chat with you and talk about discipline and multidiscipline. So obviously, I hugely admire your work in robotics, but as a seamstress, I also hugely admire your work in the field of creating clothing and fashion. Why do you do this? I mean, it's not the easiest of skills. But
no, my grandma was a seamstress, and I spent lots of time with her when I was young. And from the age of 4 or 5, she would give me pieces, pieces of fabrics that she would have left from making something to somebody. And she allowed me to be creative from the beginning, and I was allowed to use a sewing machine and so on. But it felt that I invested time in something that I had like a physical proof of. I read a lot and so on. I did some sports. I'm really bad in sports. But anyway, it just didn't give me kind of like the same feeling of me pointing and saying, oh, I did that. And I suppose that it was also a very good balance to programming and mathematics and everything that I educated myself in, because it's a different type of creativity. And it's also not serious, I'm not kind of like a designer professionally. So I can do things, and people can have opinions about how it looks, especially my husband. He always has lots of opinions. But it's very much about, you can do right, you can do wrong, but it's only for you. So, and I need that. I need my free time activity to be something completely different from work.
And so, obviously you're in education, which is great. Dedicating time to pass on your skills to other people, other generations is pretty huge sacrifice, because obviously we could, glue you into big tech companies and we'd never get to see your work again. But do you encourage your students then to consider different skills? As you say, working with coders quite a long, you've got long screen time, they've got fabulous minds, but is there a way to influence that in education to maybe give them some relief, or ways to see the world a bit differently?
No, absolutely. There are a couple of things. So as an academic, I'm very often asked, so your research, kind of like how many startups did you do and so on, and then I say that, I feel that my responsibility is not to make startups myself, but to make people, or to build people that build startups. And I really strongly believe in that, because you can't, making a startup is really huge work. So you really need to keep your focus and make sure that if you think that you're good in kind of supervising people and so on, in terms of having PhD students and so on, mentoring, that's what you should do. And I really love that. And I love that because, I mean, I have family, I have 2 kids. I love to tell them that there is also life outside academia, which for some of them is, especially in the beginning, difficult to understand. But as Michaela has said, you cannot build new things if you don't come in contact with people that challenge you. And yes, as an academic, you are challenged, but the rules used to challenge us, like in terms of our citations, publications, and so on, you know them. But when you change the area, when you go to another area, and when you get a question that you understand, like, okay, you don't know anything about my research, let me tell you. I mean, it challenges the way you describe and you talk about your research. And that potentially also gives you reflection that is a little bit different than it would have if you only talk to people that do the same thing as you. So now when we talk about future robots, when we talk about systems that are there for humans and with humans, you need a good understanding of what not a human wants, but what many different types of humans want, need, are willing to accept, because I think that it can directly affect your algorithms and how you think of designing the system for the future.
And so just finally to wrap things up, looking at different disciplines and putting them together, I mean, according to me, so it's just my opinion, people can dismiss it if they want, but I think the clothing that you make is quite beautiful. I find it very appealing. When I talk to people in terms of code, it's about being functional and maybe elegant. Maybe we can do elegance in fashion in the way, but not the same way that we do in code. Do you find ways to combine these, or do you see more beauty in the code or robotics that you're doing today, or do you think that the separation is a good idea?
No, I think that this is also an important aspect because today more and more people, like Michaela said, she learned or taught herself to program out of other reasons that maybe I did. And I think that in order then to develop something that somebody else can use, you actually cannot think only about function. You also need to think about making beautiful code and that you also communicate that in a good way. And you can draw a parallel to literature. Somebody needs to be able to understand what goes beyond just the technical, because I think that that's going to be very, very important when we start to work on human-robot real human-robot interaction, although the field exists and it has existed for 20 years now. But still, really trying to understand these small differences and variations that will really make the difference. And this is exactly what you see in fashion and in clothes design. I mean, it can be very simple, but there is a detail that actually makes it so that everybody wants it. And it's very recognizable to a certain designer. And I think that this is what we don't have today. Programmers don't think about what is that makes my code beautiful. So, but I think that it's going to be needed in the future.
Well, I look forward to the future of the Gucci code.
Yeah, that would be nice, right?
Thank you very much, Danica. It's been wonderful talking to you.
Thank
Round
you.
of applause, please, for Danica.
Thank you.
Amazing stuff. Hey, thanks so much for listening to the MTF podcast. Hope you're enjoying, and if so, why not go back and find another one to listen to? There are some incredible people who've joined us at the festival, and we're going to keep on adding more. Don't forget to spread the word. Have a great week, and talk soon. Cheers.